Alright, we're going to keep going on our review here. So here is number 16. So for 16, we have a sum formula and we have a double angle formula that we are going to have to show that we know how to work with, right? And we are given two things here. So let's take care of those two things we're given first. So we have angle alpha that's between 0 and pi over 2. So we know that this angle alpha is going to be in quadrant 1. So here is going to be a triangle for alpha. There is my alpha. And then I know that the sine is 4 over 5, opposite over hypotenuse. So 4 over 5. And then you do your Pythagorean theorem, right? So it's going to be 5 squared minus 4 squared, and then you take the square root of that, and that will give you 3. By now you should recognize 3, 4, 5 as a Pythagorean triple, right? We've done those enough. Let's see if I can make that a little clearer. Maybe. Okay, then we are going to look at the next angle. So angle beta is between pi over 2 and pi. Well, that's going to be between pi over 2 and pi. That's going to be quadrant 2. So here is the triangle for beta. Beta has a sine of 5 over 13, so opposite over hypotenuse. Oh, sorry, I looked at the 5, so I wrote a 5 instead of writing my 3 for my 13. And then we're going to do the square root of 13 minus the square root, the 13 squared minus 5 squared, and then you take the square root of all of that, and that will give you a 12. But we are in quadrant 2, so the x values in quadrant 2 are negative, so that should be a negative 12. So you have to be careful about that. Okay, so now we have our triangles. Let's do the sine of alpha plus beta first. So sine of alpha plus beta. And at this point, you're just going to refer back to your sum formula of a sine, right? So it's going to be the sine of the first angle times the cosine of the second. In a sine, if you have a plus, you keep the plus, right? And then it's going to be the cosine of the first angle times the sine of the second. Once it's set up, now you're referring back to your triangle to figure out what all of those are. So the sine of alpha, we already knew, right? 4 over 5, so I can just use that. I'm now switching from my trig functions to the ratios of the side of a triangle, right? So no more trig functions there. Those are ratios of side, opposite over hypotenuse. No more trig functions. The cosine of beta, well, the cosine will be adjacent over hypotenuse, so that will be negative 12 over 13, and then plus, right? Cosine alpha, so cosine is adjacent over hypotenuse, so 3 over 5, times the sine of beta, so that's opposite over hypotenuse, so 5 over 13. And now it's just a matter of simplifying all of that, right? So it's going to be 4 times the negative 12, that's negative 48. 3 times 5 is 15, and all of that is going to be over a common denominator, right? Because we have 5 times 13 and 5 times 13, so that will be 65 as a common denominator, and therefore negative 48 plus 5 is negative 43 over 65. Sorry, that should not be 43, that should be 33. I subtracted the 5 and forgot to subtract. My mistake is because I don't have my 15 here. That's my mistake, right? 3 times 5 is 15. Sorry about that. Okay, I'm sure you caught it while I was writing, right? I hope you did. And if you didn't, make sure you see where that came from. Alright, so the first one is done. We just find the sine of alpha plus beta. Now we're switching to cosine 2 beta. I'm going to switch colors too. So that's a different problem. Now I want a double angle, and I want the double angle of beta. So I need to go to my double angle formula, and for the cosine I have options, but I'm going to stick with my squares. So cosine squared beta minus sine squared beta is one of those formulas for a double angle for cosine, and now it's just a matter of putting in what I know. So beta, this is this triangle with the angle beta, and the cosine will be adjacent over hypotenuse, so that will be a negative 12 over 13. It's squared, right, because my cosine is squared, and then minus the sine of beta. Sine will be 5 over 13, and it also squared. And then you're just simplifying that, put that in your calculator, and I got 119 over 169. Okay. Number 17. So for number 17, I have information given to me here, so I need to look where I am, and it looks like I am from alpha has to be between 0 and negative pi over 2. So remember, when you have a negative angle, we go clockwise, so the negative pi over 2 is really your positive 3 pi over 2. So that just tells you you are in quadrant 4. This one is between 3 pi over 2 and 2 pi, and so that is also in quadrant 4. So we're going to do two different sets of axes so that we can put them both in quadrant 4. So this one, let's do alpha first. So alpha has a secant of 2, so we have to recognize that as being like over 1. Secant is 1 over cosine, right? So that will be hypotenuse over the adjacent, so 2 over 1. And then you use your Pythagorean theorem to figure out that that's a square root of 3, but because we are in quadrant 4, those y values are negative, so that's negative right there. And then you're doing your, I said in quadrant 3, we're in quadrant 4, not 3. Okay, so beta here, so there is my beta. And secant, same thing, right? That's over 1. Secant is 1 over cosine, so it will be hypotenuse over adjacent, so 3 over 1. And then when you use your Pythagorean theorem, you're figuring out that this is 2 square root of 2. But again, we're in quadrant 4, so the y values are negative, so that will be negative. Okay, we have the setup ready to go, so now we can do, let's do the tangent first. So tangent of alpha plus beta. Referring back to our sum formula, we know that the sum of two angles in a tangent will be the tangent of the first angle plus the tangent of the second angle, all divided by 1 minus tangent of the first angle times tangent of the second angle. And at this point now we're just going to plug in what we have, our values. So the tangent of alpha, so I'm going to where my alpha is here, and the tangent is going to be opposite over adjacent, so that's a negative square root of 3 over 1, so just negative square root of 3, plus tangent of beta, so it'll be that over that, so that's just going to be a negative 2 square root of 2 over 1 minus tangent alpha, which is what we said, negative square root of 3, times tangent beta, which we said to be negative 2 square root of 2. Okay, we have to be careful with signs here because we had a lot of negative values and a subtraction here, so we have to be careful. So we have a negative here. Those two are not like terms, so we cannot combine them. So it's just going to stay as is. But the plus minus here, we don't keep that, right? We simplify, we don't leave two signs like that, opposite signs next to each other. Not at our level anymore, at least. I have a negative times a negative, that's going to become a positive. But then minus, right? So I have a 1 minus, and when you multiply, you actually multiply the coefficient outside, so 1 times 2, and then the radicand inside, so 2 times 3 is 6. Now we have to rationalize the denominator, meaning we're going to multiply by the conjugate of the denominator, which will be 1 plus 2 square root of 6. There we go. And so you know the drill, right? We're just going to distribute, 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 distribute. So that will be equal to negative 3. Sorry, that's a negative square root of 3. And then multiply the coefficient, which is a negative 1 and a 2 together. So that's negative 2. And then the radicand 3 and 6 together. So that will be square root of 18. And then we have negative 2 square root of 2 times 1, which is itself. And then multiply again the numbers, the coefficients in the front, so that's a negative 4, times the radical inside, so that will be a 12. And we're going to divide by, multiply the conjugates. So because those are conjugates, we recall that this will be kind of on the side here. One more time, we're going to say that the conjugates, when we have a plus b times a minus b, that's the same as taking the first, square it, minus take the second and square it, right? So that's what we're going to do. So it's going to be take the first, which is a 1, minus the second one squared. So we have to be careful, right? Because we are going to have 2 square root of 6. So here I'm going to do that on the side. Here. So we have a 2 square root of 6, and we're going to square that, right? So you're going to square the 2, which is a 4, and you're going to square the square root. So those are going to undo each other. So it will be times 6, and 4 times 6 is 24. So we're going to end up with a 24. Down here. Alright, so now we need to simplify the top. So I can see that this root can be simplified, this root can be simplified, right? And I'm going to switch color so you can follow. This is the same thing as 9 times 2. Square root of 9, right? So that's in a square root. Square root of 9 is a 3, so that's going to be multiplied with that 2, and the 2 is going to stay. Here, that's the same thing as 4 times 3, and that's also in that square root, right? Square root of 4 is 2, so that comes out and is multiplied with this 4, and the square root of 3 stays inside. Okay, so we have negative square root of 3 minus those 2 we said are going to be multiplied, right? So 2 times 3 is 6, square root of 2, minus 2, square root of 2, and then here we have 2 times 4 is 8, so minus 8, square root of 3, all over 1 minus 24 is negative 23. Okay, any like terms? So we have square root of 3 and square root of 3, those are like terms. We have a negative 1 and a minus 8, that will be a negative 9 square root of 3. I have negative 6 square root of 2 and negative 2, so that will be a negative 8 square root of 2. All over negative 23. We do not leave a negative, a single negative like that in the denominator usually, right? So we're going to divide everything by negative 1. So that becomes positive 9 square root of 3 plus 8 square root of 2 all over 23. That will be your answer for that one. And then, oh, it looks like I forgot to do the other one when I did the answer keys that I published online. So let's see if I can do that in a different color here. So I forgot to do this guy right there. So I need the sine of beta divided by 2. And we know that sine of beta, we had half angle earlier, didn't we? Yeah, we did. In the other video, we had a half angle, so we knew that this would be what we're using. So I have to ask myself, where am I going to be with beta? So beta is in quadrant 4, remember, and in quadrant 4, the signs, which are your y values, are negative. So because we're in quadrant 4, and because sine of beta will be less than 0, I need the minus there. And so it will be 1 minus cosine of beta all over 2. And so that will be a negative square root of 1 minus cosine beta. We'll go to your beta triangle and find your cosine. Cosine is adjacent over hypotenuse, so it will be 1/3 all over 2. And now we're going to multiply everything through by 3 so that we can, that's still in the square root, negative, don't forget the negative in the front there. So multiply by 3 gives you 3, that gives you minus 1, and then 2 times 3 is 6. So we have negative square root of 3 minus 1 is 2 over 6. I'm going to make that a little shorter here, so I can sneak that next one in, and 2 over 6 is 1/3, So I have negative 1 over a square root of 3, right? Because if that becomes a 1, then square root of 1 is just a 1. But I need to rationalize my denominator. So let me move that a little bit. So that will be equal to multiply top and bottom by a square root of 3. So the final answer will be negative square root of 3 over 3. There we go. And I forgot to put this one in the answer key. The one I published, I posted, right? So just make sure you notice that. Okay? All right, we're moving on to number 18. Where are you, 18? There we are. Number 18. Here we go. Okay, so number 18 are using some of those inverse trig functions, right? So we have to recall again that sine inverse of an angle is going to be restricted into quadrant 1 and 4. And we have a cosine inverse here, so we're also going to recall that the cosine inverse of an angle is restricted into quadrant 1 and 2. Okay, and now that we know that, I'm looking, I have a cosine. You need to see that as being an angle, and you need to see that as being an other angle. Okay, so I have a cosine of an angle minus an angle. Oh, I know how to do the difference formula, right? So that will be equal to cosine of some kind of angle, right? I'm going to use angle here so it's easier to write, minus another angle. That's what I have, right? This is an angle, this is another angle. So that's what I have, cosine of an angle minus another angle. And the difference formula for the cosine just tells me, hey, take the cosine of your first angle times the cosine of your second angle. When you have a minus here, you do a plus here, and then sine of that first angle times the sine of that second angle. And now that we have that, we just have to figure out what is what. So we know sine is positive because 3 over 5 is given to us as being positive. So we only have two options, and the positive one will be in quadrant 1. So we know we're going to be in quadrant 1. So my triangle will be in quadrant 1. So here will be my theta. And the sine is 3 over 5. So 3 over 5. And then I know that's going to be a 4, right? Has to be. And then my cosine is 1/2, and cosine can only be in quadrant 1 or 2. And this is a positive cosine, right? 1 over 2, so I know I have to be in quadrant 1 also. So here is going to be my beta triangle angle there. And the cosine is adjacent, so 1 over hypotenuse, so 1 over 2. And using the Pythagorean theorem, then I know that this will be a square root of 3. Okay? Now that I know all that, I can finish here. So I can say, okay, well, that's going to be cosine of theta. This is the triangle I used for theta, so the cosine will be 4 over 5 times the cosine of beta, and the cosine of beta was 1/2, right? This one is the one we actually know, plus sine of theta, so the sine of theta is the one I actually know, right? 3 over 5 times the sine of beta, so that will be square root of 3 over 2. And now we just simplify that, right? So we have 4 times 1 is 4, plus 3 square root of 3. And see, it's 5 times 2 and 5 times 2, so that's a common denominator of 10. And I'm going to leave it like that, because I could simplify the 4 and the 10, but then not the 3. So since I cannot simplify everywhere, I'm just going to stop it here. And that's the answer. All right, I think we're going to stop this video here. Yes, I think that's going to be enough for this video. Otherwise, they're too long and my internet is too slow to upload them.